Section 2. Interactive Speaking Companion. In this section, we will create a 3D avatar companion, which will be summoned on a detected plane in the real environment. We will be able to guide the model around and implement audio streaming functionality with parametric jaw movement. In the first section, we broadened and deepened our understanding of the AR landscape, and we built our first AR Foundation cross-compatible app. In the following sections, we will focus entirely on building useful apps by implementing multi-platform AR Foundation API. In this section, we will make the first half of our first interactive AR app, AR Foundation API in depth. Before we dive into development, it is useful to get a closer look at the AR Foundation API. Let's start from refreshing AR Foundation package website and inspect it in more detail than we did in section 1. Unity Engine Experimental XR namespace will accompany us throughout the course. For instance, when we try to check trackable ID, raycast hit pose, or determine alignment of a plane, all of which we will cover. Unity Engine AR Foundation namespace wraps low-level experimental XR with specific functionalities. Our calls will refer to one or the other namespace depending on the context. We are already aware of the main concepts in AR Foundation. Let's look at some components. AR Session is responsible for managing lifecycle of our AR app. You can start, pause, or stop the session at any point, which makes AR Foundation very flexible. Once resumed, the session will attempt to recover previously detected features. AR Subsystem Manager provides us with the status of subsystems and the AR session through monitoring events and state changes. In the previous Unity video, aside from AR Session, to build AR Foundation app, we needed AR Session Origin object with AR Camera as a child. AR Session Origin determines the position, rotation, and scale of objects in the space. It is crucial to understand that scaling AR Session Origin means scaling everything in the scene. We will get into more detail of it in the second project of the course. Tracked Pose Driver is Unity XR component used across XR SDKs. E.g., it enables rendering to one eye, and it got extended to AR Foundation. It links the camera's local space to AR's session space. We will explore it deeper in the third project of the course, but just to give you an example of its use, if we utilized AR for position tracking in VR, we could enable only position tracking type and leave rotation to be handled by a VR SDK. In such a case, AR camera background component would be disabled to dispense of the device's camera feed and yet keep the position tracking active. In AR Foundation, we can copy our camera texture to render texture for persistence and/or multiplication. Next, we see different types of AR managers we already implemented in the previous video. They are useful for visualization, and their names are rather self-explanatory. These components subscribe to AR events and can visualize them if we add prefabs in the inspector. All the trackables in the session have trackable ID, except for the point cloud, which can only be represented by a single game object. This is naturally due to performance considerations. Let's skip the tutorial details of creating visualizers. We will revisit them later in the course. The last stop is raycasting via AR Session Origin, which will be useful to us in the following video, particularly the first method below. It takes two-dimensional position from the screen and translates it to a hit on a detected plane or other trackable type, such as a feature point. The second method additionally adds an angle to the hit via ray. It might be a lot to take on, but these are still fairly rudimentary elements of AR Foundation. In the future, our point of reference will be Unity Scripting API focusing on XR AR Foundation namespace.